has spinach got to do with database development? Generations of children were fed spinach in preference to more nutritious things such as cardboard because of the persistence of bad data. It wasn't in fact the decimal point error of legend, but confusion over the way that iron was measured in the late 19th century data. As a result, nutritionists persisted in believing for generations that it was a rich source of iron that the body needs in order to create blood cells. In fact, the very little iron that there is in spinach isn't in a form that can be readily absorbed by the body anyway. The consequences of bad data can be dire. Guarding the quality of your data is about the most important thing that you as a data professional can do. You may think that performance is important, but it would just deliver you the wrong answer faster. Resilience. It would just make it more likely that you'd be able to deliver the wrong answer. Delivery? Yep, you've got it. The wrong answer quicker. The spinach example is a good one because bad data is hard to detect and can go unnoticed for generations. This is probably because people don't inspect and challenge data as much as they should. You would have thought it strange that a vegetable like spinach should have 50 times as much iron as any other vegetable, but the fact came from a very reputable source, so people just shrugged and accepted it. We have a touching faith in data. We as a culture assume it's correct and complete. We like to believe that it's impossible that either prejudice, bias, criminality, or foolishness could affect the result. Worse, we think that valuable truth can be sifted from any data, no matter the source. If there's enough of it, then there must be value in it. It's like panning for gold dust from a river. The sad truth is that this is a delusion, but very common in our society. We are, in our mass culture, in the Bronze Age, rather than the Information Age, struggling with silvery toys imbued with mystical, magical powers. A good database professional must be unequivocal. Bad data cannot be cleaned in the same way that one can clean mud off a diamond. If data contains bad entries, then the entire data set must be rejected. There's no such thing as data cleansing. You as a DBA may be asked to take out data that's absurd, such as ages that are negative, or ages that are so great that the person couldn't possibly be alive. But then that leaves you in the same data set, data that's plausible but wrong. Only in very exceptional circumstances, when you know precisely why a minority of your data is wrong, would you be justified in correcting it. Statistics can help us make fairly confident assertions about large data sets if they conform to one of the common distributions, but they cannot tell us anything about individual items of data. You can, of course, remove outliers, but in fact, outliers are just items of data that don't conform to your assumptions about the data. And the whole point of data analysis is to test your assumptions. By cleaning data, by removing outliers, you can prove almost anything scientifically. A well-designed database is defended in depth at every possible opportunity. Depth is actually an interesting analogy because experience tells us that bad data seems to leak in under pressure through every crack when a database is working hard, like you'll see in a World War II submarine movie. In a well-used OLTP database, we are like the crew, swivelling our eyes in terror, savouring the futility of any remediation as the ghastly drips run down the walls of our database, and wishing we'd put in more constraints. In terms of the defence of data, check constraints and foreign key constraints are excellent, of course, and triggers are good. But there are other ways of getting warnings of errors in data, such as sudden changes in the distribution of data and other anomalies. One check I like to do is a tourism check, where you check your data all the way through back to source. This technique once famously picked up the fact that a famous motor manufacturer was reporting its deceleration figures in yards per second when it should have been meters per second. When you start putting in check constraints, you say to yourself, this couldn't possibly happen. This is the voice of superstition. A famous programmer of the 1970s took to putting a message in his code saying this error could never happen. And he put it in places where it couldn't ever possibly be executed. And the funny thing was that the more he tested the program, the more that error appeared on the screen. And it's the same with constraints. The more traps you set, the more critters you catch. And you're left wondering how on earth all that bad data was getting in. It's misleading to go on about the value of the great flood of big data. There's a strong superstition that data has some sort of intrinsic, mystical value all of its own. Unless you can prove that data is correct, it's valueless. Because if you trust it, you could end up with generations of children being compelled to eat spinach for no good reason at all.